I'm Zachary Combs, the R&D Director for Energy Systems at Birla Carbon. Birla Carbon is one of the world's leading manufacturers of carbon black with more than 150 years of production experience and an annual carbon black capacity exceeding 2 million metric tons. We produce more than 100 unique grades for different applications at our 16 manufacturing sites around the world. That includes 2 manufacturing sites in the U.S., as well as our global technology and business headquarters, which is located outside of Atlanta, Georgia. Birla Carbon has recently made a net zero by 2050 announcement, which is a first for the carbon black industry. In the energy storage market, we have an emerging material strategy, which is focused on developing a full carbon portfolio, including both natural and synthetic graphite, as well as our existing carbon black conductive additives. We can support this industry with our existing global sales and tech service footprint, as well as synergistic product integration and feedstock security provided by our sister Aditya Birla Group companies. Birla Carbon's full carbon portfolio provides unique solutions for both conductive additives as well as anode active materials. Conductex I-14 is the flagship carbon black conductive additive product designed specifically for the lithium-ion market and has shown improved performance, including higher solids loading, as well as high rate and high voltage performance. The second product line is a carbon black carbon nanotube hybrid system, which provides the dispersion characteristics of a carbon black with the high conductivity and low loading characteristics of a carbon nanotube. And lastly, and probably most importantly for growth into the energy storage market, is our development of synthetic and natural graphites as anode active materials using a new-to-the-world process. To support LiBridge, Birla Carbon has identified some key U.S. market growth challenges. These include access to capital and equipment, particularly for the value-added graphite processing steps. This also includes raw material manufacturing knowledge, having realistic scale-up plans for production, and including a skilled workforce to support this production. And in the U.S., this all must be done with an environmentally sustainable process that may include something very different than what's used today to manufacture graphite around the world. Birla Carbon offers some distinct advantages for these challenges, including existing energy-positive manufacturing assets in the U.S. that could provide potential co-location and rapid scale-up for graphite manufacturing. We've also developed a new-to-the-world graphite manufacturing process, which is targeted to lower CO2 emissions and high yield. We can also leverage existing certifications and a long history of supply to the automotive industry for accelerated approvals. Thank you for your time, and please reach out if you have any questions regarding Birla Carbon's energy systems product portfolio and growth strategy.
I'm Chad Potter, President and CEO of Westwater Resources. I'm here at our site just outside of Kellyton in Coosa County, Alabama. We're building our first of its kind graphite processing plant that will produce refined battery-grade graphite for electric vehicles and many other commonly used products. Our graphite refining plant will use a proprietary and thoroughly tested process that we developed that is both environmentally responsible and sustainable. None of the raw materials we use will come from China, and beginning of 2028, we intend to source our raw graphite to feed our refining plant just miles away from here in the deposit-rich Alabama graphite belt. With our plant and future mining operations, we'll be investing more than $700 million in central Alabama, creating over 100 good-paying jobs and providing a boost to this rural area's economy.
Most of the world's graphite comes from China. Westwater plans to be a major U.S. supplier of battery-grade graphite products. During 2021, we completed our pilot processing program and a definitive feasibility study, acquired a site for constructing our commercial-grade graphite processing facility, and purchased 2 buildings for the use of administrative offices, laboratories, training, and warehousing space. With the acquisition in 2018 of mineral rights for more than 40,000 acres in the Alabama graphite belt, Westwater is uniquely positioned with a U.S.-based graphite resource. Previous exploration work indicates natural flake graphite in quantities that likely exceed 1.9 million tons. That's an estimated 30-year supply. Development and permitting of the Coosa deposit is planned over the next few years, with mining anticipated to start in 2028. In the meantime, a source of natural flake graphite concentrate, other than from China, has been secured. Without the use of hydrofluoric acid, our unique purification process is not only environmentally sustainable, it's also safe for workers and produces an extremely pure product that has the potential to increase the performance of all battery types. We took great care in locating an ideal site for the construction and operation of a commercial scale facility to produce our graphite products. We're appreciative of the support we have received in Alabama, from the governor and her administrative and legislative leaders to local county and city officials. And we're proud to bring jobs and hundreds of millions of dollars in investment to this racially diverse area. Our core values call for continuous improvement in safety, cost management, and integrity.
As you can see, our Coosa Graphite project easily meets the intent and requirements for investment by the DOE under the Bipartisan Infrastructure Law. Upon completion, our project will be the only fully integrated graphite production facility in the U.S. We're providing a homegrown source for graphite. We're investing in American manufacturing and American workers. And we're doing it all right here in the United States of America.
Hi, my name is Daniel Higgs, and I'm here with Forge Nano to talk to you today about how we are a U.S. manufacturer of equipment for nano coating of battery materials. My colleague will be talking separately about how we are also a U.S. battery cell producer. Our investors include LG Chem, Air Liquide, VW, Sumitomo Corporation of Americas, and Mitsui Kinzoku. So let's dive straight in. We have a technology that can replace pitch coating. Pitch coating is currently used to make graphite anodes stable enough to withstand the harsh environments of a lithium-ion battery. However, pitch coating is expensive, it's dirty, and it's not environmentally friendly. We have developed a high throughput, one-step continuous process using high purity chemical sources to produce a lower cost, higher performance, and lower environmentally impactful technology. Our technology is currently at TRL 9 for our generation 1, and generation 2 is shortly behind that at TRL 7. This technology has been invested in by and validated by the US Department of Energy through their various subgroups listed on this slide. So our plan for US manufacturing of anode graphite powder includes partnering with various graphite production facilities. With them, we are investing over $500 million into graphite mining, graphite refining, graphite purification, and coating as well. We provide the coating equipment, which can process 4,000 metric tons of graphite anode powder per year, and that equipment is made in Colorado. We have a very high throughput nano coating technology, and that technology lowers the cost and the environmental impact of the graphite production while improving the battery performance. We are requesting that the US government speeds up permits for natural graphite mines, coordinates with the Canadian government to enable easy flow of natural graphite powder from Canada to the USA for processing, and also to continue to support green technologies. We also request that workforce investments are made in various engineering fields, as well as solid-state chemistry, mining, material science, and battery manufacturing. Forge Nano is following the executive orders 13985, 13990, and 14008, and working closely with Washington to support a comprehensive approach to advancing equity for all. Specifically, we're targeting partners in underserved communities and expanding our own climate tackling technology in Colorado to provide jobs, training, and support for traditionally disenfranchised and historically self-reliant communities. So with that, I'd like to leave you with a few quotes from our various partners, including the DOE, and please feel free to email me at dhiggs@forgenano.com. Thank you.
ACPT was founded with the objective of producing high-value, low-cost, strategic materials using low-value fuel oil as feedstock. Through the use of its patented process, ACPT stands to reduce our nation's dependency on China for our strategic materials by converting this carbon-rich feedstock into the base material for graphite, carbon fiber, carbon-carbon, and other materials that are critical to our national security. The resulting materials sequester the carbon that would otherwise be burned and released into the atmosphere, making this an environmentally friendly way to produce these materials in America.
We are a R&D focused company that owns a patented process that takes a low-cost petroleum product and converts it into mesophase pitch. ACPT views the development of the development of our technology, the commercialization of our technology, as one step of creating a new industry in the United States, the production of synthetic graphite and other graphitic materials.
In the past, container ships burned their petroleum waste. With new guidelines in place, they are no longer able to do this. Refineries are left to look for alternatives to meet their disposal needs. The ACP Technologies process provides a solution by utilizing petroleum byproducts to create mesophase pitch. The ACPT process not only enables the nation to produce the strategic materials it needs, but does so in an economically and environmentally friendly way. Our patented process will lower production costs, and it is a sustainable, green process that will also eliminate the need for foreign production, allowing us to produce and manufacture products and components in the United States. This will enable domestic production sources for several national priorities, like the electric vehicle market, hypersonic flight for the DoD, lightweight vehicles and equipment, as well as reduced signatures of DoD equipment.
So with the DoD's focus on electrification and in general industry focus on electrification for vehicles, there is a real supply chain problem where most of the critical materials that go into a battery, the rare earth metals and the graphite, are sourced from foreign countries. And we are a potential source, a domestic source for a critical material, the graphite that goes into the batteries. Currently, ACPT operates a pilot facility in Hitchens, Kentucky. Our pilot plant has successfully ran its process for 90 hours at a time. And we are seeking to expand that pilot capability by leveraging our partnerships with the federal agencies that we work with and our industry partners to create our first commercial sized plant.
Thank you for the opportunity to share our insights in the electric vehicle and battery material supply chain. I'm Chris Burns, the CEO and co-founder of Novonix, an advanced battery material and technology company with operations in Chattanooga, Tennessee, and Halifax, Nova Scotia. Our mission, to make batteries better through materials that will support longer life and lower cost cells for vehicle and energy storage applications, with a strict adherence to environmental and social responsibility. Novonix is the only battery-grade synthetic graphite supplier with plans to bring large-scale production to North America. We're preparing to invest hundreds of millions of dollars over this decade, beginning with the expansion of our Chattanooga facility, in close partnership with the local community to create hundreds to thousands of good-paying, clean energy jobs. Public-private partnerships like LiBridge are essential to effective policymaking and fostering certainty for American business investment, which is essential not only for developing new battery technologies, but today, more than ever, critical for scaling manufacturing of current technologies. We cannot do this quickly enough. Investing in the production of synthetic graphite offers the United States the ability to build capacity now to meet the immediate demand for electric vehicle batteries, rather than continuing to rely on importing key materials from foreign countries and primarily China. In the United States, we can produce synthetic graphite using clean sources of power and domestic sources of high-grade precursor to create an end-to-end American supply chain for this key battery material, which is the best proven anode technology to deliver high energy density and long-life batteries. Public support for the synthetic graphite industry, such as low-cost debt or loan guarantees, will help drive scale and manufacturing efficiency, which is critical to achieving cost competitiveness with the existing Chinese supply chain. For context, Novonix recently raised capital to support 10,000 tons of synthetic graphite production coming online in 2023. Our competitors in China have companies adding tens or hundreds of thousands of tons of capacity per year with significant state support. Of course, domestic support for EV adoption and manufacturing in the United States must remain a top priority. And we applaud the Biden administration's commitment to EV expansion and the foundation laid by the bipartisan infrastructure law. We also applaud the administration's recent step to formally recognize graphite as a critical material of importance for national and economic security. Overall, to develop a robust battery material supply chain at home in the United States, the government must prioritize Make It in America across industries, from EVs to defense to battery cells and raw materials. Finally, trade policy must align with our domestic policy goals. An appropriate tool to account for externalities and anti-competitive behaviors that skew free markets and act as a structural bar to industry growth here in the United States. The Biden administration has made clear its commitment to strengthening domestic supply chains and American manufacturing. And at Novonix, we believe this is a bright future, and we remain a committed partner to this goal. Thank you.
Greetings. It's a great pleasure to present again to the U.S. Department of Energy about the battery materials manufacturing supply chain. My name is Ian McCallum. I'm the Chief Growth Officer at Amsted Graphite Materials. I'm here to talk about the critical need to expand synthetic graphite anode manufacturing capacity in the U.S. for domestic lithium-ion battery production. We are Amsted Graphite Materials, an experienced manufacturer of synthetic graphite anode products. We're proud to note that Amsted Graphite is North America's only fully integrated synthetic graphite anode manufacturer currently in commercial production, qualified by and shipping to an electric vehicle application. We share headquarters with our parent company in Chicago and operate multiple locations in the U.S. In addition, and central to this presentation, is our ongoing activity engaged with manufacturing expansion. I'll provide more about that in a minute. First, synthetic graphite and natural graphite are significantly different, yet both are required for lithium-ion batteries, particularly for EV applications. China's dominance of over 90% of synthetic graphite anode production and growth is risk to our strategic interests. But on the bright side, accelerating demand suggests much further room to grow here. The opportunity is clear. The U.S. must establish synthetic graphite anode manufacturing capacity as fast as possible. Amsted Graphite has assembled the pieces necessary for success. The key topic here is manufacturing capacity. The issue dominates every customer conversation. Amsted Graphite is already executing on two parallel paths. Number one, the pilot plant. From here, we service existing customers and new smaller U.S. battery makers. We conduct R&D and we continue in-progress qualification processes with large battery cell manufacturers and OEMs, thus accelerating their path to accepting and confirming a U.S. supply base. Number two, expansion plant. We're already in phase 2 for selection site of plant number 1. We're starting the engineering and equipment specification process and raising capital for multiple facilities. A partnership with DOE and others that we're bringing to the party is critical to accelerating these plans and successfully meeting the national supply chain security objectives of this administration. These themes, taken collectively, represent our unique market position. First and most important, we are in commercial production and shipping anode product to customers today. We're 100% domestically owned and operated, and our pilot plant operation scale is 5,000 tons of annual capacity for graphitization and about 500 tons of finished product capacity. Soon to be officially announced, we are actively working on multiple expansion plants, each at 30,000 tons capacity. We have over a century of operating and graphite materials science expertise with a team with deep battery knowledge and expertise. Finally, our pilot plant utilizes hydropower, and our expansion sites are uniquely targeting sites with clean energy access. Our sites aim at being the anode solution for the North American market. Together, we can secure the domestic supply chain of our electrified future. Thank you, and we look forward to further discussions.
The future of energy storage. Innovative materials from Farad Power for next-generation batteries and supercapacitors. Our advanced carbon and carbon composites-based platform technology eliminates the use of current supply chain constrained materials, including cobalt and nickel. Instead, we utilize renewable, biomass-based raw materials like sugarcane, bagasse, and corn cob with zero or negative value. Join us as we create an alternative supply chain ecosystem for next-generation sustainable battery materials. Farad Power, advanced carbon technologies for next-generation applications.
My name is Ed Carney. I'm Chairman and CEO of Superior Graphite Company. Today I'd like to talk to you about the need for speed and how continuous high-temperature furnace technology can allow America to catch up in the battery arms race. Superior Graphite was founded in 1917 and is a fourth-generation, family-owned, partial ESOP company. It has 3 manufacturing operations and 2 R&D facilities. Our journey in energy materials began in 1994 when we developed a unique material for alkaline cell batteries and has continued to expand into other formats, including fuel cells, lead acid, and lithium-ion materials. Today we have our 2 commercial lithium-ion battery grades, which are based on our proprietary wet coating process. We continue to also develop our unique in situ coating method, and that will continue on through 2022 when we will have a fully continuous line producing such materials. In the next slide, I'll talk a little bit more about our high temperature furnace technology. But the takeaway on this particular slide is the fact that it can purify and graphitize natural flake graphite, synthetic graphite, and recycled anode material. There's a lot to consume on this particular slide, but the 4 main points are that it's continuous, and materials are going through and transformed in a matter of minutes at process temperatures at roughly 2,500 degrees C with 99.5% scrubbing efficiency. There are many benefits to continuous high temperature technology. First of all is the cost efficiency on the OpEx side due to high throughput, and on the CapEx side through the physical footprint. In addition, you have energy efficiency, consistent quality, and an ability to utilize a number of source materials. Here's what it can do in terms of metallic impurity. Where do we perform this magic? We do it in 2 places, in Hopkinsville, Kentucky, and Sundsvall, Sweden. Together we have 10 operating furnaces capable to produce approximately 70,000 tons of material on an annual basis, and have produced well over 1 million tons of product since we've developed this technology 45 years ago. Today we're able to utilize our 3 pilot furnace reactors that operate on kilogram scale per day all the way up to 1 metric ton per day. At our lab outside Chicago, we're able to offer a number of electrochemical and conductivity testing capabilities. In short, we are LIB ready to purify and coat natural flake, synthetic, and even recycled anode material through our pilot furnaces, and we'll build out our auxiliary systems in 2022. And this is how it could happen. Thank you.